In this video, a schematic from an experimental shortwave receiver. I've really made it in the past, but I've demolished it, so I cannot show whether it works, and I cannot give a real demo. But it really works. I've built this circuit many times, also in my other radio circuits, and I'm sure it works. I have to pen over the circuit. The drawing is not very clear, but anyway. At first stage from this shortwave radio. This coil, now in the middle of the screen, sets the frequency where it receives the radio stations. It's made on a plastic tube, PVC tube, yellow tube, and wound with a wire that's insulated with plastic. When you stick in a ferrite rod, frequency will go down substantially. But for shortwave, 10 windings from that wire on that tube from approximately 1.8 centimeters gives a good shortwave coil. This cap you see now is 44 picofarad, is fixed, but when you change that into a variable capacitor, you can tune in the radio on different radio stations. First transistor is a very simple BC547B. In fact, audio transistor, not typically high frequency, but works very good. Resistor 1K, a 470 picofarad cap is the coupling capacitor to the next transistor, that's also a BC547B. And the working point is set with this potentiometer, 50K. Now in the middle of the screen. In the collector lead we have the IF transformer. The radio uses only one IF transformer, and that's this IF transformer here. It's from Mitsumi, but I'm sure other IF transformers will work properly too. And the print on the IF transformer is 2033017 and then HT. Inside the transformer is a cap that's now in the middle of the screen, and that IF transformer is coupled to a field effect transistor, a BF245B. That makes that it has a good Q. The Q from the IF transformer stays properly, and after that the signal is coupled out to another amplifier stage, again with the BC547B, and this is done via a 470 picofarad capacitor. This is an amplifier. Here is the AM detector, OA81, a 1N90 will also do. It must be a germanium diode. And finally another stage, another amplifier stage, and the whole circuit works on 2.4 volts. So again, amplifier stage now in the middle of the screen, detector stage, in fact impedance transformer here, the BF245B. And with this potentiometer you have to set the working point. It's a real superhet receiver, because here we see the VFO. The VFO couples its signal in to the emitter from this transistor via the capacitor that's now in the middle, 300 picofarad. You have to find out the value from that coupling capacitor experimentally. And this is finally the VFO schematic. The VFO oscillates 455 kHz higher than the frequency that the antenna receives. So this coil oscillates 455 kHz, must be tuned 455 kHz higher than this coil. And the difference is of course the IF frequency. You can set the oscillator to work by means of this potentiometer, 5K. now in the middle of the screen. And here is the capacitive voltage divider that is very critical for good oscillation, and 4 N7 and 1 N5. So 4700 picofarads and 1500 picofarad. Also here a very common transistor is used, the BC547B. Not a typical high frequency transistor, but the whole circuit works with these transistors up to 9 MHz. I've used only one IF transformer because of the simple fact that the tuning is very simple. You set at first the mixing process, of course set the oscillator first to oscillation with this pot meter, then set the mixing process, connect your antenna, do that via a 10 picofarad capacitor when you have a long antenna. That gives much more selectivity. Also, this oscillator works on 2.4 volts, so 2 batteries. I have received quite a few stations with the circuit, and as I told, it works really. I've tested it. When you want to make it, I wish you luck.